All right. I think we are live.
All right, let's complete this.
Fuck's sake, mate. Mm-hmm. Check, check, check.
I think we did completed the tutorial for this.
1 second. Yes. Oh, my wrist is hurting as well, bro. But we move on regardless. All right. So, yeah, we did I think we are at the last part, and I was not able to like understand correctly what that part exactly meant. This is Primbas rendering with USD. Value resolution, time code, value clips, transformation. Yeah, step 7, I guess. Cause I need that whole. Okay. Hmm. So this was the part we were trying to understand. In this previous step, we noted that the tops are spinning once they reach the final knot. Spleens are supported. Spleens support extrapolation as mentioned earlier, so we can use this to have top spin continuously. We can make the small change to the way we set the spleen for the X form OP rotate Z spin attribute by setting the post extrapolation for the spleen to TS dot extrapolate loop repeat. This extrapolation mode will repeat the entire spleen forever and automatically compute an offset between loops using difference between the first and the last knots. The extrapolation mode will repeat the spleen forever and automatically compute an offset between loops using the difference between the first and the last knot. Oh, okay. Add spin spleen with extrapolation. So this is the method that does that. The code is spin is equal to top dot add rotate op operation or op suffix is equal to spin attribute is equal to spin dot get attribute. Type name is equal to str spin attribute get type name. Spleen is equal to ts dot spleen type name. Spleen is dot spleen dot set not ts dot not. Type name is equal to type name. Okay, okay. We make a similar change to the way we set up precession to ensure this animation also repeats. Precess. What was exactly precession? The
Slow movement of the axis of a spinning body around another axis due to torque.
such as gravitational influence acting to change the direction of the first axis. It is in the circle slowly traced out of by the pole of a spinning gyroscope. Hmm. Okay, we then create the animated layer with these new spleen configurations and repeat the code from the previous step that references the animated layer three times with different layer offsets. Create animated layer that uses spleen extrapolation. Stage is equal to make initial stage step ref 7 ref dot USDA stage dot set metadata comment step 7 ref adding spleen extrapolation top is equal to add reference to geometry stage slash top add precession with extrapolation. Okay, add offset top, add tilt top, add spin spleen with extrapolation top.
I think we did this yesterday, I guess.
I know, bro, we did this. I am just trying to take a look at the code, why, how it is. Okay, so left is getting the same treatment, middle, and then in the third, so this code is same as the previous one.
Mm-hmm.
State order comment step 7 spleen extrapolation. Yeah, this is the usage add precision with extrapolation on top. So this is the method that they're gonna use on the top. Add reference to geometry. What does this do? Add reference to geometry?
Where is it? Add
This one.
reference to geometry. Uh, search. It's a function, custom function that we have created.
I know that, bro, but
Look for that function. I would just look for that function. It should be mentioned up
no,
above.
it's not mentioned over here.
Do command F on that. See,
Okay, step 2, yeah. What does it do? Let's add reference to the static top model using USD reference API. Yes.
just you. It's using only add reference onto that state. That get
Add
reference
reference.
and then the top geom dot USD.
I see. Okay. 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 So the main thing over here to note is the extrapolation and the type of extrapolation. TS dot not is doing that extrapolation. I think it's this. No. TSPLEAN class reference, a mathematical description of curved function with time to value. Hmm. TSPLEAN default constructor creates spleen without a value type. The value type becomes established when the first node is added. Creates a spleen with a specified value type.
Oh,
Okay. Yeah, I think we can move to the next tutorial now.
mm-hmm. What's the next tutorial?
Simple shading in USD.
Simple shading in USD. All right. So the tutorial demonstrates how to create a simple texture material and bind it to a geometry in USD. In it, we make a model asset, add some simple geometry to the model, make a material to contain shading data, add a surface shader to the material, add texturing to the surface. We create the scene using a simple model, add geometry and a material with a simple shading network into the model, and then bind the geometry to the material. To fully illustrate these concepts, we walk through a Python script that performs the steps using the USD Python API as well as showing the result text.usda outputs. The relevant script that data files resides in the USD distribution in USD extras, USD tutorials, and simple shading. What? The
Oh, okay. So this tutorial basically is teaching how to create a simple textured material and bind it to a geometry in USD. Okay. We in it we make a model asset, add some geometry to the model, make a material to contain shading data, add a surface shader to the material, and add the texture to the surface. Okay, we create the scene as a simple model, add geometry and a material. Um with simple shading network into the model, then bind the geometry to the material. To fully illustrate these concepts, we walk through the Python script that performs the steps using USD Python API as well as showing the resulting text.usda outputs. The relevant scripts and data files reside in the USD distribution, USD extras tutorial, simple shading. Alright, animated top is done. We can close this out, clear this. And simple shading, generate simple shading. Okay, this is the script, and this is the USDA file. All right. In the directory capture the script examples from the tutorial step below in the one script that can be run to produce the final version of simple shading USDA. For convenience, pre-generated version of simple shading USDA that would be produced after the following tutorial step is provided. So, uh, hmm. All right, we can do our own kind of thing.
Mm.
Test shader.py where we can basically copy the steps of what's been instructed over here. So basically the first thing we need to do is create a container that will hold both geometry and the shading prims. Yeah, so this is one of the concepts that is being repeated time and time again. We basically are creating some sort of a holder or container to add both the geometry and the shading prims that we will create.
Mhm.
We could have created a mesh and material prims at root scope in the scene, but by putting them both under a common model prim, we make it possible to reference this asset as a whole into other scenes. In a Python shell, execute the following. Python shell.
Yes.
Why does it want it to be a Python shell?
Not a script, brother. It should be a Python shell.
I don't know how to bring the Python shell. Is it shift? How is
Type Python.
Python and enter?
Yeah.
Hmm.
There you
Uh,
go. There is your shell. Paste now.
yeah, we might need to change. Alright. REPL stage equals to USD dot stage create new simple shading dot USDA. Will it override the file that we already have?
Hmm?
We already have a file called simple shading dot USDA.
Oh, so we are
So
trying to override it or what?
no, I have they are like they have just provided us with that file for the future reference, but I'm
Oh.
saying if we run that, is it going to override that file?
Wait, let me create
Because the
new.
names are same.
Oh yeah, definitely it's gonna override it because it's
So
saying
let
doing
me change the name of this file then.
backup, do backup.
Where is rename? What the fuck? Rename. Fine. There's the model API model root set kind dot tokens dot component. So model root is equal to USD dot xform defined. So this is defining an xform prim on the stage as text model. USD model API model root dot set kind dot tokens dot components. Okay. Adding a mesh billboard. In the interest of simplicity and brevity, we stick with a very simple piece of geometry, a quadrilateral billboard with a texture ST texture, coordinate. Bro, wait, I need to understand first what is an ST texture.
You it's dude, it's the same UV texture, right? Okay. Primvares, and it's a texture coordinate that we use to define the texture value. Okay. Yeah.
a crab bandage. An ST/UV texture concept is about using 2D coordinates on a 3D mesh so an image texture knows where to land on the surface. In USD, the common name for UV texture, UV coordinates is usually the primvar ST, and a shader reads that primvar to drive a texture lookup. A coordinate, 2D coordinates on a 3D mesh so an image texture knows where to land on the surface. In USD, the common name for UV coordinates is usually the primvar ST. The NVIDIA exam guide explicitly includes primvars, USD preview surface, materials, assignment, and creating a shading network that reads diffuse colors from a primvar. So this is very certification relevant. What do you need to do? 3D mesh. Image texture knows where to land on the surface. Mhm. A 3D mesh has points in 3D. A texture image is 2D, horizontal, vertical. A texture image is 2D, horizontal, and vertical. So we need mapping 3D surface point maps to 2D image coordinate. That 2D coordinate is called UV coordinate in general DCC language and ST coordinate in USD shading language. Oh, horizontal texture direction and vertical texture direction. I didn't know this. Vertical texture direction. Simple mental model. Imagine peeling the skin off a cube and laying it flat. 3D cube. Okay, UVST layout. This corner of the mesh should read this part of the image. That face should read that part of the image. That mapping is the UVST map. Why is it called ST in USD? In DCC tools, people say UV is UV texture map and UV map. In USD, the standard texture coordinate primvar is commonly named primvar ST. Example, text code 2F primvar ST. Interpolation. This mesh has a texture coordinate. Each coordinate is a 2D float pair. The primvar is named ST. The values are used to place image textures on the mesh. What primvar st mean? Break the name apart. Primvar's namespace saying this is a geometric primvar. Name of texture coordinate primvar. So primvar st, the mesh is standard texture coordinate data. It is not the texture image itself. It is only the coordinate system used to sample the image. There is no texture image, so it is no okay texture image. The actual image file like brick.png, metal base color.jpg. The 2D coordinates telling where that image lands on the mesh. The material logic that reads the texture and applies it to the surface. USD mechanism for storing per geometry data like color, UVs, masks, etc. Simple pipeline, mesh surface has firmware ST coordinates. Firmware reader float to reads ST, USD, UV texture samples image using ST. USD preview surface receives color slash roughness slash etc. Object appears textured. Mesh with ST coordinates. Hmm. Okay, I think I know enough. USD UV texture dot input ST. Okay. So adding a mesh or billboard in the interest of simplicity and brevity, we stick to a very simple piece of geometry. A quadrilateral billboard with a ST texture coordinate that maps the corners of the quadrilateral to unit square in UV texture space. Note that we do not create any normals for our mesh. This is because by default meshes use Catmull-Clark subdivision. To change the subdivision scheme, use USD geom.mesh.create subdivision scheme attribute, which provides analytical computed normals to a renderer. Catmull Clark means smooth, right? Or no?
It's smooth, but it's a different kind of algorithm. Both Catmull-Clark and subdivision scheme, both are smoothing algorithm, both of
Mm-hmm.
them. But they have different type, the different ways on how they calculate the smoothness of the curve.
Mm-hmm.
That is a major difference between them. Like the algorithm is different,
Mm-hmm.
but both of them will do the same thing: smoothness, smoothing out the curves.
Mm-hmm. Mm. Analytical computed normal renderer. So we need to run this in the script or in the shell, I guess. Let's take a look at what we have so far. USD view simple shading.usda. Mm-hmm. Simple shading dot USDA. Oh, bro, I think the fucking file was edited.
Corrupted or
No, I don't think it was corrupted. It looks the same. But I don't see that file. I don't know why. Invalid syntax, simple shading dot USDA. But I don't see that file though. How can we run that file?
which file are you talking about? The simple
Simple
shading.usd.
shading dot USDA.
Did you created it?
Oh, oh. Where did animated top? What? Animated top. Does animated top have simple shading dot USDA?
Yeah, there it is.
Where do you see
Won't
it?
for dude look at
Oh,
the yeah.
why the fuck did? Oh, because I see. I fucking wrote Python in animated top.
Hmm.
Mm, okay, never mind. That's how it worked. Accidents. Two accidents. Two wrongs make one right. Over here.
Wow.
That was said by the great whoever that was. Oh, I think it was two wrongs don't make one right.
My god, crazy analogy.
Whoever the fuck said that is wrong himself. Now, okay, so we have created a mesh billboard. Make a material. In USD, we bind geometry to material prims in order to customize how the geometry should be shaded. A material is a container for networks of shading prims. A material can contain. In USD, we bind geometry to material prims in order to customize how the geometry should be shaded. A material is a container for networks of shading prims. Okay, a material is a container of networks of shading prim. Hmm. A material can contain one network that defines the surface illuminance. Material can contain one network that defines the surface illuminance response and another that defines surface displacement. I am not able to understand what this statement means, like this whole
Which
paragraph.
in USD we bind geometry to material prims in order to customize how geometry should be shaded. A material is a container for networks of shading prims. A material can contain one network that defines the surface illuminance response and another that defines surface displacement. It also contains different networks for different renderers that don't share a common shading language. Complex model will define material area. Just give it to ChatGPT. Crazy shit. Just give it to ChatGPT. I
Bruh.
quite I was able to complete the shit out.
Let's see our old friend Gemini, how that does. Are you able to hear the music behind me?
Yes, brother.
Hear it completely now. Oh, illuminance. Sounds like
Luminance.
sounds like a Spanish word. Illuminance. Illuminance. Personalita.
Personalta.
That is a fucking meme, bro. Personalita is actual Spanish.
Oh my god, oh really?
Personalita. So read this, bro.
Okay. Imagine you are building. Hold on. What the fuck? Imagine you are building a 3D model of a car. Have you have the basic 3D shapes model, but right now they just look like plain gray clay. This text explains how USD Universal Scene Description give those shapes their final realistic look. The core concept simplified. Banding geometry to material. Banding simply means assigning a specific look to a specific 3D shape. For example, you are linking the 3D shape of a car door to a red paint look. Materials are containers. Think of a material not just as a single color but as an envelope holding a set of detailed visual instructions. One instruction sheet dictates the surface luminance response, how light bounces off the object, example making it look like shiny metal versus dull rubber. Another sheet dictates surface displacement, adding actual physical texture or bumps to the shape, example the grooves on a tire or dimples.
Oh,
Multi-language support, different 3D programs, the software that calculates the final image basically speak different coding languages. The material container is smart enough to hold these instruction sheets in multiple languages at once. That way, no matter which rendering software you decide to use, it knows exactly how to read the instruction and make object look right. Hmm. complicated 3D isn't object isn't made of just one material. A 3D car model will bind the tire shapes to a rubber material, and then the window shape to a glass material, and the body shapes to the metallic paint material. In short, a material is a master folder of visual instructions, and binding is simply telling the computer which part of your 3D model gets which one. Oh,
Uh,
crazy shit.
so let's read this again. In USD, we bind the geometry to the prims in order to customize how the geometry should be shaded. A material is container for networks of shading prims. A material can contain one network that defines the surface luminance response and other that defines surface displacement. It can also contain different networks for different renderers that don't share a common shading language. Complex models will define multiple materials binding different geometry to different materials. In our model, we have only one G prim and therefore need only a single material. Let us create it. Material is equal to USD shade dot material dot define stage text board mat. What is this API? USD shade dot material, and we are using that API to create a new, defining a new material prim. In our model, we have only one G prim, and therefore we need only a single material. Let us create it. Okay. Add a USD preview surface. The most important shader in our material will be the surface shader. We create it, and any other shaders in the network as children of the material prim. This is what it means for the material to be a container for the shading network and is an important property to preserve. We set the surface's metallic and roughness properties to get familiar with setting shader input properties. We set the surface's metallic and roughness properties to get familiar with setting shader input properties. Any input whose value we do not set will be bro. What the fuck is this?
What happened? Just dude, give the whole thing to ChatGPT. I would say if the whole party, bro. Whole party. Oh Lord.
The tutorial builds one complete USD shading setup, a model frame, a mesh card, a material, USD surface shader, preview surface shader, texture node, a Primva reader for ST coordinates, a material into onto the mesh, material binding onto the mesh. The key exam idea is geometry does not own the material directly. USD binds geometry to a USD shade dot material, and that material contains the shader network. The NVIDIA exam guide directly lists three visualization skills: assigning USD preview surface materials, binding materials to a mesh, and creating a USD preview surface shading network that reads diffuse colors from a primware.
Texture, primware, material. The key exam idea is geometry doesn't own material directly. Used dividends the exam guide directly lists this as a visualization skill, assigning USD preview surface material, binding materials. The big picture is scroll down, brother, for the big picture.
1 second. The tutorial builds one completely model frame, a mesh card, a material. Okay. Geometry does not own the material directly. USD binds geometry to USD shade dot material. What does this mean? Binds geometry to USD shade dot material. What the fuck does that mean? And
So,
material
okay,
contains a
what is
shader
that you're not
network.
able to understand in that line? Like, okay,
What
let's.
is geometry and why is
What
it?
is
How is it
geometry?
getting binded to?
So, what do you understand about geometry right now?
What is geometry like? Is it like the coordinates of the billboard or like a quadrilateral?
Yes, the coordinates, the structure, the skeleton. This is what a geometry is.
And but
Eventually,
how is that binded to USD shade dot material?
now you take a material. Sorry, you take the geometry,
Yeah.
right? So let's use this Kindle
Mm-hmm.
as for example. We have this Kindle. What is the geometry of this Kindle? What do you see?
Whoa, like a square or something.
Right? Let's say square or rectangle. I would go with rectangle.
Yeah,
A
rectangle.
cuboidal rectangle. If we go with more
Yeah,
like
cuboidal rectangle. Yeah,
cuboidal.
cuboid. Yeah.
Now imagine it without anything that you're seeing right now, just the edges and
Yeah, you
small
basically peel it open. Like you just
peel it open, and
yeah.
right now you have the skeleton. That is what we call as geometry,
Mm-hmm.
right? For this,
That will
you
be
got
like
to
the
involve.
coordinates of all the edges. Sorry,
Yes.
all the vertices.
Now it's saying that you have to bind your geometry to a material. So what it means over here is, let's say you are taking this area of the geometry and you
Mm-hmm.
bind it with the material. That is, you wrap the geometry with the material.
You
That's what
basically put in the values in USD shade dot material to say, okay, from 1, 0, 0 to 4, 0, 0.
interpolation. Interpolation. This is where interpolation
Yeah.
occurs. You say that this
Okay.
is going to be black or it's going to be some kind of material.
Okay.
So that's what geometry means over here. And then when you bind it with the material, then that specific material is only binded to
And
that.
okay, and then what is the second part? That material contains a shader network.
So now how material is connected with the color?
Mm-hmm.
Recall what we have learned till now. So you have material, and then you have the shader node network that will have a kind of an input that it will take.
Mm-hmm.
Recall diffuse color as an input color,
Mm-hmm. What?
as
What?
diffuse color as an input. You recall there was a USD preview surface API that we were using, and then you had to take in namespace inputs, and then the diffuse color. You have to take namespace variables. Look at
Mm-hmm.
look at diffuse texture and the primware SD card over here, the texture coordinates and everything. Wait, I think
Mm-hmm.
if you scroll down, we might have go more down.
No, wait, I'll go step by step. Let me.
No.
Okay,
I
the
just want to
tutorial.
show you the example. Try to going more down because it's going to tell you everything, but I'm just want to see if it's okay. No,
What
it's
are
not
you
okay.
trying to?
Yeah,
Bro,
I
let
think.
me read this 1 second.
Let's read it.
So the tutorial creates this structure text model root container card mesh geometry, prim bars st, texture coordinates, board mat material. So board mat is the material. Okay, I think that's what we created. Yes, this is what we created. It was a new material. Material prim. And that will have USD preview surface, PBR shader, diffuse color texture. Okay. Now I get it. So now we are adding a preview surface, USD preview surface. What is exactly a preview surface?
It's a shader area.
So that is a PBR shader, preview surface.
Yes.
I see. The most important shader in our material will be surface shader. We create it and any other shaders in the network as children of the material prim. Okay. This is what it means for material to be a container. Ah. So the shaders are inside the material container for the shading unit and is an important property to preserve. We set the surface's metallic and roughness properties to get familiar with setting shader input properties. We set surface's metallic and roughness properties to get familiar with setting shader input properties. Any input whose value we do not set will be filled by the renderer with a fallback value defined in the shader specification. I see. So I think we get the roughness and the metallic properties as a schema attribute, I guess.
Yes.
So if we don't set it, it will go back to the renderer will go to the fallback value defined in shader specification. After creating the shader, we connect the material surface output to USD preview surface output. Hmm. This is what identifies the source of the material surface shading. This is what identifies the source material. So PBR shader USD shade dot shader dot define. So this is using USD shade dot shader API, and this is going to be defined over here. PBR shader dot create ID attribute USD preview surface. PBR shader dot create input roughness.
SDF dot
SDF
value type.
value types. PBR shader dot create input
So
metallic
these
SDF.
inputs would be connected to your shader network. That's what the statement was. These
Material
inputs.
dot create surface output. Connect to source PBR shader connectable API. Hmm.
What is this background sound coming? Like some trippy song.
Yeah, it's some. I think there is some new band that is performing in the club.
Oh, in the club. I thought at your home you were saying that. Wait, who's performing at your
The Delancey, I don't know, somebody. I think there is a band.
home?
I was seeing a lot of line. Yeah, this is the Thursdays at Delancey. Groovy moves upstairs, Latin energy downstairs. Oh, you can even see the guest list, bruh. A lot of people are going. How much is the ticket? Buy tickets from $0. Oh,
No one's coming.
before 11 p.m. Damn. Ah. I might have to go party here one day, maybe next Friday
Go to it, bro. Do it.
before LA after the certification. Yeah, bro, I'll take one day break at least before going to LA. Or no, I won't. All right. Holy shit. Okay, so this is where it is connecting the material surface output to the preview surface output.
Yeah.
Hmm. Let me run this as well. True. And then add texturing. The last step to add a texture as the source for the surface is diffuse color. Hmm. The last step is to add a texture as the source. The surface is diffuse color. Texturing requires two nodes in the shading network, a USD UV texture node to read and map the texture, and a USD primware reader, more precisely a USD primware reader float 2. The implementation that reads the float 2 array valued primware S to fetch a texture coordinate from each piece of geometry bound to material to the material to inform the texture node how to map surface coordinates to texture coordinates. Hmm. Hmm. Texture requires two nodes in the shading network, a USD UV texture node to read and map the texture, and the implementation that reads float to array valued primvar S to fetch the texture coordinate from each piece of geometry bounds to material to inform the texture node how to map surface coordinates to texture node coordinates to texture coordinates. ST reader USD shade.shader define text models ST reader create ID attribute USD primvar reader float to diffuse texture sampler USD shade.shader.define stage text model board mat diffuse texture sampler dot create ID attribute USD UV texture create input file SDF dot value type names dot asset dot set USD logo LRG dot PNG diffuse texture sampler dot create input st sdf value type names dot float to connect to source streader dot connectable API result diffuse texture sampler create output RGB SDF value type names dot float 3 PBR shader dot create input diffuse color SDF dot.
Dude, crazy.
There's a guy in the chat, by the way.
Yeah, dude, crazy background sound.
Oh,
Like party vibes.
let me switch it back to. Yeah, look at the chat.
You are great. You can give me some advice on how can I learn LLMs and AI, what resources and how to make projects. By the way, learning and practicing ML, dude, it's on you.
Go
It's for you.
to Freed Code Camp. Go to Free Code Camp's YouTube channel and take a look at all the MLAI videos. How to create an LLM from scratch and stuff like that. Read a research paper and start building projects. That's the advice I can give in 30 seconds. Free Code Camp. Don't waste any money on Udemy or Coursera and shit courses like that. Do go to the it's let me see if I have the link over here. If you are watching, go to this. If you wanna learn everything about computer science. cs50.harvard.edu/x. This has helped me immensely. If you're like bootstrapping your software engineering journey and you know, this is the place to start. Complete this. It's a very tough course. Like it's not easy. It's gonna take you probably like 3 or 4 months to complete. Do the problem sets, grind a little bit. I lack coding skills as intermediate level. Yes, this is going to help you immensely. This is gonna teach you everything about data structures, what are pointers, what is memory, what is, you know, stuff about database. Um, yeah, I'm not a very good coder myself because I'm an AI native software engineer, but you know how it goes. That's how it goes. All right, I'm gonna get back.
Mm-hmm.
Uh, bro, I wish my brother could listen to me and, you know,
Send
but
him the link. Send him the link.
no, I'm not gonna send him the link, but I'm just saying that he's not doing software engineering, bro. He quit engineering.
It's fine, brother. Some people are born artists. Born
Bro, I
artists.
have so many resources to help him out. Like he wouldn't have had to struggle like I had to,
Mm.
but it's all right. The last step is to add texture as the source for the surface diffuse color. Texturing requires two nodes in the shading network, a USD UV texture. Yeah, we already read this. Okay. I think I'm gonna just run it. Paste. Node that we have not yet special. Wait, diffuse texture color sample. What is this doing? USD shade dot shader define stage. So it is defining a diffuse texture on board mat. This is defining a ST reader. And oh, so this is so this is just creating the inputs for the PBR shader.
Yeah.
And this is creating the new prims that are ST reader and diffuse texture.
Yes.
and then you diffuse texture sampler create ID attribute. So this is gonna create a new attribute called USD UV texture, and then it's gonna create a new input, which is gonna be file sdf.value type.asset.set USD logo large.png. So there is a PNG file that it's gonna use as its file input for diffuse texture sampler. Ah, I think it's gonna use this one.
Mm.
Oh my god, this is so gaudy.
Gaudy?
Gaudy.
Gaudy, oh
Gaudy.
my god. Gaudy, Gaudy.
Do you know what it means?
Big, blurry?
No.
No? I thought that's what it means. Big and blurry.
Gaudy, bro. Showy, flashy, overly ornamented.
Oh, oh my god.
GRE word.
Gaudy.
I went GRE on your picture.
God.
Bro, GRE actually helped me improve my vocabulary a lot, not gonna lie.
Yeah, me too, bro. I use Mambeen. Mambeen.
What's that?
Mambeen is like a vocabulary tool that you can use to create mnemonics.
I used to use this, what was that? Fucking app. I forgot the fucking app's name. I don't know. There were like some word, like there was an app that you could like use.
Mm-hmm.
Yeah, I don't know. Okay, so yeah, I was gonna do the. Okay, so it is creating that input file and then input of texture sampler sdf value type names float2. Okay, so this is an asset data type and this is a float2. Connect
Mm-hmm.
to source st reader connectable API result. So this is something that we are gonna put in, I guess.
Hmm.
And then diffuse texture sampler create output RGB SDF dot value type names dot float3. So PBR shader dot create input diffuse color SDF value type names color 3F connect to source. Hmm. 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 Bro, do you know there's this guy on the Discord.
Mm-hmm.
He did the same thing. He got the certification, but he did the
Mm-hmm.
same thing. I think he used Cloud Code to do that, and he shared this repo on that Discord today.
Mm-hmm.
And look at what he is. This is the PDF he has shared. I think he did the same thing with Cloud Code.
Mm-hmm. Mm-hmm. Yeah, bro, I'm telling you, the only thing that we did not do was going through that exam guide thoroughly. I think that's the point where we missed.
Look at him, OpenUSD certified professional. There's a fucking study, quick review study. Damn, bro, he PhD, OpenUSD development, LinkedIn Hashim. It's crazy.
FlexMax.
Flex
Flex,
Max,
FlexMax.
Hashim Sheikh. Let me take a look at him. Ruben Diaz. What is it? Dot in Hashim Sheikh. Hashim Sheikh PhD. Oh, he's from New Jersey.
Overall, it's your neighbor.
Not my neighbor, bro.
Neighbor.
Mammoth Junction. He is not my neighbor. He lives, I think, in South Jersey or something.
Oh my God.
Thrill to share that I have achieved the NCP OpenUSD. Oh, he tagged everyone. He made sure they liked this.
3, 2, 1.
Why are all the old people doing this shit?
I see.
I'm getting very skeptical of OpenUSD, bro, because the type of people that are doing it is crazy.
Huh.
Mhm. He was at Qualcomm for damn. He has some crazy experience, bro.
I think even he's not able to find a good job. That's why he's trying to switch to OpenUSD.
Gen AI architect. Geopolitical disruptors risk, oh, bro. I think I will connect with him here from the NVIDIA Omniverse community. Thanks for sharing the Git, the resources. Happy to connect. Done. Let's see. A note from author as well. Yes. These notes started as my own scratch pad. Damn, bro, he really went on with the freaking Claude code.
Yeah, bro.
Oh no, I think he did do some stuff himself because I remember this diagram is from one of the
Stream.
documents. No, no, no. Oh
Mm.
yeah, it's from one of the streams actually. I think Austin.
Yeah.
Yeah, liver peas. Okay, anyway, fuck that. Mm-hmm. Deep work, bro. Deep work. Let's do deep work. Note that we do not have yet what textual coordinate firmware reader should read. We could author the name of the firmware directly as its var name input. However, we instead demonstrate how we can connect the shaders inputs to public interface attributes on materials. Any input in a shading network can connect to an input on its own on its enclosing materials, and the renderer will migrate the material inputs authored value, if any, to any shader input connected to it before. Rendering and shading begins. In effect, this gives us a way to expose inputs deep in shading network for easy overriding by consumers of the material. Since all the inputs on material will be exposed and editable without needing to look inside the I'm not I don't know what the fuck that is. Oh my god. We could author this name of the primware directly on its varname input. However, we instead demonstrate how we can connect shader inputs to public interface attributes on materials. Any input in a shading network can connect to an input on its enclosing material, and the renderer will migrate the material input's authored value, if any, to any shader input connected to it before rendering and shading begins. In effect, this gives us a way to expose inputs deep in a shading network for easy overriding by consumers of the material. Since all the inputs on a material will be exposed and editable bro, can you understand this part? What the fuck they are trying to say?
We have not yet specified which texture coordinate. Primware, the primware reader should read. We could author the name of the primware directly on the var name input. However, we need to demonstrate how we can connect shared input to public interface of material. Any input sharing can connect to material.
Oh, wait. Any input in a shading network can connect. Any input in the shading network can connect to an input on its enclosing material, and the renderer will migrate the material's input authored value, if any, to a shader input connected to it before rendering and shading begins. In effect, this gives us way to expose inputs deep in a shading network for easy overriding by consumers of materials. Since all the inputs on a material will be exposed and editable without needing to look inside the material, which may contain many shading frames. Okay.
So I'm able to understand partially that it's showing it's
Connecting
showcasing.
yeah, it's basically connecting the
Yeah.
materials input
But
to the shaders input.
they would do it by using the namespace thing, I guess. But over here, they are not using that thing to connect. They are instead of using a direct input to material input authored value,
Mhm.
like the USD view UV texture, ST, and RGB. Those are like direct input.
Mhm.
Hmm.
Uh, okay. So st input material dot create input frame st primvar name sdf dot value type name dot token st input dot set st st reader dot create input var name sdf dot value type names dot token connect to source st input. Let me see if I have any meetings tomorrow. Otherwise, we can. No meetings tomorrow.
Wow.
I have two meetings, but they're optional.
Napoleon Fulliner Jr. Who the fuck is Napoleon? Dude, every other OpenUSD certified developer is creating their own documentation.
Yeah, bro. Because cloud code.
Uh, but his notes are pretty good. I've been going through his notes, like the PDF file that he
Mhm.
has provided us. Is like it's really good. Not like copy paste, but yeah.
I see, bro. I think it's time that I post a Instagram dump. I have enough pictures now.
Do
Or
it.
should I do it after LA? I'll do it after LA, actually.
Do it after.
Bro, we don't have a fucking good video of us skiing, bro. I just found like one video where we were like fucking around.
We don't know how to ski first of all. So how would I would have a good video? So let's go to Colorado this time and get a good freaking video.
For sure, bro. This year I'm gonna fucking do snowboarding. Fuck everything else. Our dumbasses were carrying skis up the fucking hill.
Yeah, bro. But I'm telling you, this time we're gonna nail it. I just need to invest in a snowboarding pad.
Hmm. Bro, why do I not have any pictures with the big dog?
Because the big dog was like, bro. And dude, when it's time for taking pictures, dude, you sometimes you're like, no, I don't want to take any pictures. So nothing can be done, brother.
Bro, big dog, not
And
me.
big dog he always has his hands in his pockets, yeah, to keep himself warm.
In his heated jacket. Hmm. Alright, bro, let's get back to it. I think.
Alright, bro. Let's complete this and then we will end the stream.
Yeah.
Alright, yeah, let's get back to it then. Come on, let's go.
Okay. ST reader, okay. 1256. Fuck me. Know that we have not yet specified what texture coordinate. Yes, okay. ST input. Let's do this. Yeah, we'll complete this documentation and then we'll just quickly read the what ChatGPT has to say.
Mm-hmm.
And is it doing something over here or no? And lastly, apply material binding API on the billboard prim. Bind the mesh to our material and save the results. Yes, sir. So is ST input material dot create input ST valid of token ST reader create input var name ST valid of token connect to source binding API on the billboard from binding the mesh to our material and save the results. Billboard get prim apply API USD shade dot material binding API USD shade dot material binding API billboard bind material stage dot save. Ah, I see. Bruh, it didn't even render. Why? Oh, because I think it does not have the access to that file.
Oh, the USD. Oh,
It's in this, right?
if you brought it with the correct path, it might.
Huh? Yeah, I think now it should. Yes, sir.
There we go.
Billboard in USD 3D and with texture. Oh, AI. Oh, we're done. Done.
Nice.
Let's read this and then. Okay. The shading flow is mesh primware ST, USD primware reader float to, output float to texture coordinates, USD UV texture sample, USD logo large dot PNG, USD preview surface dot diffuse color, material dot outputs surface, bound to text model card, making a model container. The tutorial starts by creating a USD stage, setting the stage up axis, defining text model, and making it as a component model. The reason is practical, placing geometry and materials under the same model. Prim makes the asset referenceable as one unit in another scene. For okay. Hmm. Visual diagram. So mesh text model card primware ST shader ST reader info ID primware reader float to output result. Shader diffuse texture info ID USD UV texture input file USD logo large PNG inputs ST I think this link would have been in pipeline and development. Sorry, visualization tutorial. No, it's not. Okay. Bind materials to a mesh. Primbar ST shaders, ST reader info ID. The essential either texture norm, bro. I think making a model container. This we understood. Imports USD modules needed for geometry, shading, scene description types, and model kind metadata. Stage equals to USD dot stage. Create new simple shading dot USDA. That's we get this. What is a model container? Create an X form prim add text model. This is big. This becomes the root container for the asset. What was the root container? Text model is the root container, which is an X form, which is X. Okay, kind as component. Prepend mesh card. Interpolation, prepend API schema, material binding API, def material board, token, output surface connect, text model, board, mat, PBR shader dot output surface. Board mat. Where is board mat? Oh, board mat, yes.
Board mat.
PBR shader dot output surface, PBR board mat diffuse texture dot outputs RGB. Text model board mat dot inputs frame. Okay. Text model board mat aesthetic order outputs result. Okay. So marks text model as a model of kind component. Why model container is a prim. What it is, a model container is a prim that groups assets, geometry, materials, and other assets, local contents. Why it matters when another scene references this file, it can reference text model as the complete asset. I examine and look for phrases like reference this asset as a whole component model, asset root, default prim, model hierarchy. Bro, I think this is the 8% of visualization that they're gonna ask for sure. Because this is literally everything that they have mentioned over here. Assign USD preview surface materials for asset visualization, bind material to mesh, create USD preview surface shading network to read diffuse colors from a primware, add primware to a mesh. This is exactly like the whole thing. Okay. We did the adding the mesh billboard. Next, the tutorial creates a simple quad mesh called text model card. It has 4 points, one quad face, an extend, and a texture coordinate primware named ST. The tutorial says the quad maps its corners to the unit square in UV texture space. Billboard is equal to USD geom dot mesh dot define. Billboard is equal to USD geom dot mesh dot define. Yes. And text coordinates. Okay. It has 4 points, one quad phase, an extend, and a texture coordinate primware named ST. The tutorial says the quad maps its corners to the unit square in UV texture space. So plain English breakdown. What? This is not plain English breakdown. What the fuck? Oh, sorry. Creates a mesh prim. Authors 4 3D points of the quad. This mesh has one face and has four corners. Face uses point 0 1 2 3. Authors the bounding box. The This is important for imaging bounds, your computation selection and culling. Creates primvar st a texture coordinate primvar. Okay, texture coordinates dot set maps the four mesh corners to the four corners of the image texture space. Bro, I'm not able to understand this part. Creates primvar st a texture coordinate primvar, right? And then it
It's
is
look at the line below. Maps the four mesh corners to the four corners
yeah,
of the
yeah.
image texture
So
space.
what is where is primvar st coming in play over here? I know it has four mesh corners to four
Yeah.
corners of the image texture space.
So remember, st is an array over here. That's the variable, primitive variable, right? So st is our array variable that takes care of that value, the whole coordinates, UV coordinate system. So look at the Python code again, like
Mm-hmm.
highlighted area.
Yeah.
So texture chords dot set. So based on this, we can assume that it's gonna be an array, and st is gonna be text coordinate 2f array, as we can see create from var. Look at the value type name over here. What is the value type name? It's a 2f array.
Text code to FR.
Yeah, right. And then what is the tokens? USD token dot vari. Because
Mm-hmm.
of that, we already know the st has a variable type that is going to be an array. That's why we are going to put it as an array over here.
Mm-hmm.
And that's where the st variable comes in.
This creates something conceptually like def mesh card points 3f points. How deep is your love? Oh, oh, is your love? Oh, oh. Bro, I've not partied in so long. Damn, like proper party.
Body. You party in Colorado, brother.
Colorado, yeah, but it's still in December, bro. In yeah, August, September, and October. Hmm. It's only 3 months in November.
Yeah, that's what I'm telling you, bro. You party in December.
90 days. How deep is your love? Can it go deeper? I love. Mm. Def mesh card point 3f points. minus 430, minus 145, 0, 431. Okay, okay, okay. Important note about normals. The tutorial does not author normals. It explains that meshes uses Cartmel-Clark subdivision. By default, the subdivision surfaces can provide analytically computed a normal that are interest. If subdivision scheme is not authored, the fallback is usually Cartmel-Clark. If you want a pure polygon mesh, explicitly author subdivision scheme none. Yes, we have learned this. Learned.
Wait, there's no. Oh, the fallback is usually Catmull Clark.
No, yeah, fallback is Catmull-Clark, but if you want a pure polygon mesh, smooth,
Okay.
then
Wait,
subdivision scheme needs to be none.
Catmull Clark subdivision. Okay, subdivision by default.
Hmm.
Okay.
Viewing the intermediate file, the tutorial saves the stage and then suggests opening it in USD view, no material, blah blah. Making the potato prime, yes, the game, the main game. Now the tutorial creates USD shade dot material at okay. USD shade dot fuck bro. I think I need a fucking crab bandage. Oh my god, bro.
No crab bandage. Get
Oh.
this man a crab bandage.
Ugh.
Bro, let's finish the shit, bro. I'm getting sleepy.
Your
Let's finish
bitch
the.
ass is getting sleepy.
Yes, brother, my bitch ass is getting sleepy.
You can sleep when you die, bro.
Yes,
You
sir. I
have
want
one
to die.
life, one
I
opportunity.
want to die right now. I'm
One
waiting to
life,
die.
one opportunity. Will
Yes,
you
brother.
seize everything?
Yes, brother. Stop singing the Eminem song, right?
One life, one opportunity.
Stop singing the Eminem song. Do the shit. No.
Who's gonna carry the boats and the logs?
Let the other people carry the logs. I will ride with them. USD materials are containers for shit. This is.
You're looking for this fucking motivation, this
I'm not looking for
purpose.
any motivation right now. I'm already enough motivated.
What
I'm
is the purpose? Like making money?
looking for
What
sleep.
is
I'm looking for sleep. Peaceful sleep right now. So
motherfucking
fucking
the
focus.
purpose is you.
Complete this shit. Complete this shit. Stop giving me motivation porn. Stop giving me motivation porn. Okay, complete the shit. I have watched enough motivation porn. Stop giving me motivation porn, brother.
Now the tutorial creates a USD shade dot material at text model slash board mat. Yes, USD shade dot material.
USD materials are containers for sharing networks. The tutorial explicitly says that geometry is bound to material prims and material contains shading networks for surface displacement and potentially rendered specific networks.
At text model board mat. USD materials are containers for shading networks. The tutorial explicitly says geometry is bound to material prims and the material contains shading network. Okay, wait. The tutorial explicitly says geometry is bound to material prims and the materials contain shading networks. Geometry. geometry is bound to material prim contains shading network for surface displacement and potential render specific for surface displacement and potentially render specific networks. Material is equal to USD shade dot material dot define. Create a material prim under the model. This material will contain the shader network. Later, the mesh will be bound to the this material. Mm-hmm. Create material prim under the model. This material will contain the shader network. Later, the mesh will bound to this material. Uh, is not itself the shader math. It is a container and the public interface for one or more shader networks. You bind geometry to the material, not directly to internal shader node. Okay, adding a USD preview surface shader. Next, the tutorial creates a shader child under the material, PBR shader. Yes, this tutorial says that this is the key surface shader and connecting material surface output to shader's output. Key surface shader and that connecting the shader's materials. The material's surface output to the shader surface output identifies the source of the material surface shading. It also notes that unset shader inputs are filled by renderer fallback values defined by shader specification. Creates a shader node under the material. Says this shader node uses the USD preview surface shader definition. hmm So I have a question. The create ID attribute, can you define like this USD preview surface and it's automatically gonna pick it up?
Yes.
But this is not a function or anything. How?
That's so shader already knows. The shader will do it. So you are using the USD shade dot USD shade dot
Oh
shader
yeah,
node
the
network.
schema
So
API. Yeah.
shader node network already knows what input
Create ID
variables are.
attribute. Okay, create input roughness. Create input. Says the shader node uses the USD preview surface shader definition. Creates the and sets the roughness input. Creates and sets the metallic input. Okay. Oh, okay. So basically, USD shade shader. What is it? USD shader. USD shade shader has like a attribute called USD preview surface, which has in turn inputs called roughness and metallic, right?
Oh, yes.
Okay, material dot create surface output connect to source. Connect the material's public output surface to the shader's output surface. Connect the material's public output surface to the shaders. Okay. So visual diagram, material, text, model, board mat, output surface connected to shader. Output surface, shade, text model, board mat, PBR shader, info ID, USD preview surface. Inputs, roughness, 0.4. Inputs, metallic, 0.0. Hmm. Why this connection matters. Without the connection, the material exits, the shader exits, but user does not know the shader is the surface is the output of the material. Putting a shader under a material automatically makes it surface shader. Now the connection is what makes it surface shader. Adding the texture nodes uses the tutorial then adds texturing. It says texturing needs two nodes: USD UV texture, USD primary reader float to USD UV texture reads maps. Okay. Creates a shader node whose job is to float to firmware from the mesh floor. That usually means reading firmware ST. Creates a texture reader node. Said the following by sets the image file used by texture node. Connects the texture node's input ST to firmware reader's output result. Declares the texture node produces on RGB visual diagram. Okay, mesh text model primer ST shader ST output result shader diffuser texture output result shader diffuse texture info ID USD outputs RGB shader PBR shader diffuse color material board my output surface texture initial idea. The texture node needs two things: which image file I should sample, which coordinate I should use to sample it. Image file is this, coordinates primer ST from the mesh. Material but ST reader exists but it still does not know which primer name to read. The tutorial says you could author the primer name directly on the reader's var name input. Var name input, but instead demonstrate public materials. Okay, why not just let's see when estimated okay, visual comparison, hard to override material finally the button material binding to the mesh. Okay, applies the material binding API schema to the mesh prim. Standard material binding relationship from the mesh to okay, writes everything to disk conceptual USDA. Okay. Rough mesh card, prepend API schemas, rel material binding. Material binding is a relationship from a geometry from to USD geometry to shared material. It's not enough. Renderer needs to know which geometry uses that material. Exam identification look for material. Okay. Not assigned modulation combined materials geometry. Okay. Yeah, I think we can end it now.
Okay.
Mhm.